Hello everyone, my name is Samuel Esong and welcome back to my YouTube channel. In the last videos, we talked about servers, networking, and how applications run in production. Today's topic is load balancers and reverse proxies. Now, this topic may sound very senior or advanced, but trust me, by the end of this video, we will clearly understand what a load balancer is, what a reverse proxy is, why we need them, how they actually work, and how to set up one practically. If you are new to DevOps or this topic, don't panic. As usual, we will start very simple, use real life analogies, and gradually move into the technical part. Before we start, please don't fail to subscribe to this channel and also like and comment on this video. All right. The first question you would want to ask is, why do we even need load balancers? Now, let us imagine you build a web application. Now, the infrastructures used to serve this web application is just one server. Users access this server for your application, and of course, everything works very fine. Now, suddenly, your app becomes very popular. Initially, you were serving 100 users, but right now, you are serving 1,000 users. And even in the coming days, you would also be serving up to 10,000 users. Now, what will happen to your one server? Your one server now has to accept all requests, process this request, and also try to respond to everyone. So eventually, the server becomes very slow. Users will definitely see timeout, and the servers at worst may crash. This is one of the biggest problems in production systems. Now, the next question becomes, how do we handle many users without breaking our application? The answer is simply, we don't rely on one server. All right. Instead, we use multiple servers. So multiple servers run the same application and you serve these multiple servers to users. But then, even with multiple servers, a new problem appears. Let us assume this is um, all right. Let us assume initially you had just one server. Now, to solve the issues you are currently facing with one server, you provision three servers: server 1, server 2, and server 3. How does a user actually knows which one to connect to? Because you cannot tell users, let's assume the first user, you cannot tell user 1 to go to server A, and you cannot tell user 2 to go to server B, and you cannot also tell user 3 to go to server C. Now, this will be very chaotic. So instead, we introduce something in front of all servers. And this thing is known as a load balancer. So in the simplest term, a load balancer is a system that sits in front of multiple servers. So a load balancer will receive all the incoming traffic and distribute requests across these servers. So going back to our drawing board, so instead of allowing just these three servers on their own, which would be very chaotic. So we provision one server in front of these three servers. All right. So this server will be our load balancer. So what this particular server do is to distribute traffic to these guys, depending on the algorithm. So the only thing that users talk to is this guy. All right. But behind the scenes, the load balancer decides, okay, let us send this request to server 1, let us send this request to server B, and let us send this request to this other server. Now, let us see a relatable analogy. And we are going to use a bank for this analogy. Now, in a bank, customers walk in. All right. And let us also assume that we have 5 cashiers in this bank. Now, do customers randomly walk behind a counter and choose a cashier? Probably not, right? So there is usually a person, all right? Now you can refer to this person as a queue manager. Or you can think of it as someone directing people. So this person says, next customer, please go to counter 1. Next customer should go to counter 2. So you can think of this person, the queue manager, as a load balancer. So without the queue manager, one cashier may be overloaded, okay? Others may be idle. So this is the same thing with servers. So going back to our drawing board, let us assume there is no load balancer. At the end of the day, each individual servers may also be overloaded, because let us say you are still serving the same website on each of these servers. You can map this first server to, let's say, go. Let us assume your DNS name is example.com. You can map the first server example.com, map the second server example1.com, map the third server example2.com. So it is now left for you to publicize these servers. All right, but this does not still solve the issue we had with one server, because at the end of the day, over 200 requests can go to server 1, and the last 2 servers can receive little or no requests. So this does not still solve our problem or the initial problem we had with just one server. So this is why we are provisioning a load balancer here. So instead of asking users to visit these servers individually, you provision a load balancer in front of these 3 servers and ask the user to visit this load balancer. All right. So behind the scene, the load balancer is now in charge of distributing traffic to these 3 guys. So now that we understand what a load balancer does, let us look at reverse proxies. So a reverse proxy sits between users and the back-end servers. So a reverse proxy receives client requests, forwards them to the back-end servers, and returns the response back to the client. All right. You can see this as a personal assistant and let us say a boss of an organization. You don't make requests to the boss of an organization directly, you go through the personal assistant. So this personal assistant is now the reverse proxy. So whatever request you have, You give it to the personal assistant, and the personal assistant take this to the boss, and the boss gives a reply to the personal assistant, and this guy replies back to you. So this is what a reverse proxy does on the very surface. Reverse proxy may sound familiar to a load balancer, right? Well, some persons confuse these two terms. Now, a job of a load balancer, a load balancer is mainly to distribute traffic. So, a load balancer focuses on performance and availability. All right. How about the reverse proxy? A reverse proxy focuses on security. The reverse proxy also focuses on routing and SSL termination. You can also use a reverse proxy for caching. So, a load balancer is also a type of a reverse proxy. So, not all reverse proxies balances load, but most modern load balancers are reverse proxies. So, we have some types of reverse proxies and load balancers in the market. You can use Nginx. We also have HAProxy. Then AWS native, we have ALB, and also we have ELB. So for the purpose of this class, we are going to focus on HAProxy. So we are going to use HAProxy as a load balancer and also as a reverse proxy. So the HA in the HAProxy stands for high availability. So just like I said, you can use HAProxy as a reverse proxy. You can use it as a load balancer, and this guy is extremely fast, and it is also widely used in production. HAProxy can also handle millions of requests at a time. And HAProxy can also help to improve your infrastructure's reliability. So this is the high level architecture. You have the user here. The user visits HAProxy, and HAProxy relays the traffic to your backend servers. So now that we've seen the high level architecture, now there are ways to distribute traffic. All right. There are like 3 algorithms or more than 3 algorithms to distribute traffic or to load balance your traffic. The first one and the most popular one is the round robin method. So the round robin method follows a cyclic mode. So it is best for equal servers. So what happens is that, let us say you have 3 servers, server 1, server 2, and server 3. The first request goes to server 1, the second request goes to server 2, and the third request goes to server 3, and it repeats. It goes back to server 1, moves to server 2, goes back to server 3, and repeats. The second algorithm we'll be looking at is least connections. So this guy sends requests to a server with the least active connections. So you can use this algorithm when request takes different times. So back to our drawing board. Let us assume that our server 1 is currently receiving 300 requests. Server 2 is currently receiving 100 requests. And server 3 is currently receiving 10 requests. So server 3 currently is the server with the least connection. So the next request that is coming in from this guy is going to server 3, because server 3 has 10 active connections, which make it least. So we also have other algorithms like the source IP hash. But for beginners, round robin is more than enough to understand. So let us see how all of this adds up in a practical session. So we are going to do a little demo. So we are going to create 2 back-end servers and also create 1 front-end server, which is going to house our HAProxy. So the 2 back-end servers is going to serve the same web application. All right. Now we are going to configure HAProxy to load balance traffic. Then we'll test and see requests switching between servers. So we are going to use EC2 for this demo. So to see this in an architecture, this is what we are going to do. So this is our AWS cloud. All right. So in our AWS cloud, we are going to provision EC2. So this guy is going to house our HAProxy. All right. Then we'll provision another instance. And this instance is going to serve as our back-end servers. So this instance is going to serve the same application. All right. So a user will sit here. So this guy is going to visit the HAProxy, and HAProxy will in turn forward the request to this other guy. And if another user comes, HAProxy is also going to forward the request to this other guy. So by design, your HAProxy, which is a load balancer, should sit in the private subnet, and these 2 guys, which is your application, should sit in the your HAProxy should sit in the public subnet, while these 2 guys, which is your back-end servers, should sit in the private subnet. So let us go to AWS and create 3 servers. So in the AWS console, you search for EC2. So this is our EC2, and if you still don't know how to create a virtual server in AWS, I have a video that talks about virtual machine creation in the cloud. So you can go check the video out, and you can also see a video on how to connect to the instance. So I'll give this server 1 or server, because I'm going to create 3 instances at the same time. All right. So I'll come here. I'm going with the Ubuntu AMI. All right. Then I'll allow it on the free tier. So we are not going to do much customization because this is a demo application. So I already have a key. So I'm going to select the key I'll be working with. So for the network settings, I am not going to do anything in the network settings. Rather, I will be going with the AWS default VPC. So I'll go ahead and launch the instance. So we'll give AWS some seconds to create the instance for us, and we can now access the instance through our local machine. So our instance is ready, and we should go back to our EC2 dashboard, and we can see that our instance is ready. All right. So just for documentation purpose, I am going to change this to server 1. All right. Then I will also change this to, all right. Then I will also change this to server 2. Then the last thing I'll do is just to change this to HAProxy. This does not affect functionality in any case, but just for observability purpose. So now it is time to configure our servers. So the first server we are going to get access to is server 1. So I'll open up my terminal and connect to server 1. SSH-I. All right. SSH-I. Then this is my key. Then Ubuntu at the IP address. So this is our server 1. Okay. So I want this server to run a simple web page. So I'm going to install Nginx. So if I do sudo apt install, let me update first. Apt update, then go ahead to install Nginx. Sudo apt install Nginx. I'll use the -y flag. All right. So while this is working, I'll open up another terminal, then log into server 2. So this is our IP address for public IP for server 2, and I'll do the same thing on server 2. SSH-I, then my key, then the credentials. So if I hit enter, we should gain access to server 2. All right, so we are in server 2. So I am going to update the server and also install Nginx. So we are not going to configure HAProxy just yet. So instead, what I will want to do is to go back to my server 1, all right, and confirm if Nginx is running. System ctl status Nginx. All right, so it is confirmed that our Nginx is running. All right. So the next thing I will do is to go to the Nginx web root directory, which is located at /var/ www/html, and just change the welcome page of Nginx so that we will have a proof that this is serving from server 1. All right. So I will do sudo nano then /var /ww/html. All right. Then the default web page is index.html. All right. So what I'll do is I'll come to the header one and just say welcome to server one. So I'll save this and exit. All right. Then you can restart Nginx again. Sudo system ctl restart Nginx. All right. So what we will do is we'll also go to server 2 and do the same thing. All right. So we'll do sudo nano /var /ww/html. All right. Then the default page. So I'll also change this to serve from server 2. So welcome to server 2. All right, so then we'll restart Nginx. Sudo system ctl restart Nginx. So guys, now that we are done configuring our server 1 and our server 2, let us confirm on the web if truly our server 2 is ready. So I'll copy the public IP address of server 2, go to the internet and do the same thing with server 1. And also check if it is running on the internet. So this is our server 1 and this is our server 2. So we have confirmed that our server 1 is ready and our server 2 is also ready. So it is now time to configure our HAProxy. So to configure our HAProxy, we will also need a public IP address to log into HAProxy, and then we can configure our HAProxy. Ubuntu at the IP address. Confused on how to connect to a remote instance, you can watch my video on connecting to a virtual machine. So the next thing I'll do is to update the server, sudo apt update, and also install HAProxy, sudo apt install HAProxy. Then I'll use the -y flag. So give it some minutes and HAProxy will be up and running. So guys, our HAProxy is ready. All right, so let us confirm if HAProxy is truly running. So sudo systemctl status HAProxy. So it is confirmed that our HAProxy is active and it is running. So the next thing we would want to do is to go and configure our HAProxy to serve the backend servers. And the configuration file of HAProxy is in the /etc/HAProxy folder. All right. So, and the configuration file is known as config or HAProxy.cfg. So I will use the super privileged mode sudo and edit the HAProxy configuration file. So we have it in the /etc/HAProxy/ So we have it in the slash etc slash HAProxy, and the configuration file is HAProxy, all right, .cfg. So you open this up, and so let us explain what this configuration file means. So the very first thing we see is the global configuration and the default configuration. So the global section defines the global settings that apply to the entire HAProxy process. All right, so we don't literally do anything here. And the default section is like the default behavior for the front end and the back ends. All right, so this guy starts the default configuration block. So we are going to add our own section for our configuration. Okay, so the very first thing, the very first thing we will do is to add our front end. Front end, and the name of the front end, we can call it HTTP. The next thing we will do is to bind our port number. So since this is going to serve a web page, and the web page is not secured, all right, so we are going to bind port 80. So what this means is that any traffic, this should accept any traffic coming in from port 80. All right, so we are going to declare our default backend, and we'll call it web servers. All right, then the next thing we will do is to configure our backend servers itself. So we'll call it backend. All right, then web servers. So what is the mode? The backend is running on HTTP. All right, and what is the balancing algorithm we are going to use? We are going to use the round robin algorithm. The next thing will be for us to serve or to configure our backend servers. And to configure our backend servers, we are going to use the private IP addresses of our server 1 and server 2. So the private IP address of server 1 is 172.31.17.7. So I will come here and paste this. All right, and this guy is running on 80, and we also add check so that HAProxy will always keep these servers up. So the next thing we'll do is to configure our server 2, and we also use the IP address of the private IP address of server 2. So this guy here. Sorry. So this is, I repeated the same IP address for server 1. So I'll paste this guy here. All right, so the 80 and also check. So we are done with our configuration. All right, so the next thing we'll do is to save this configuration and restart HAProxy. But before we restart HAProxy, we should confirm if our HAProxy configuration file is correct. So to do this, we do HAProxy -c -f, then -f is the path to the configuration file, and our configuration file is what? Is in slash what? Slash etc slash HAProxy slash HAProxy.config. So it tells us that our configuration file is what? Valid. So the public IP address of our HAProxy is what we are now serving our users. But then there is one thing to do before we can truly give our HAProxy IP address to the users. All right. So on the network tab of our servers, of our backend servers, we are going to disable the public IP address. So to disable the public IP address, you come to network interfaces, and we have one network interface. Then we click on this adapter. All right. Then we come to actions and manage IP addresses. So you click on this adapter and disable the auto assign IP address. So we confirm, and we also do the same thing for server 1. So we also come to server 1 and repeat the same thing. So we come to networking. All right. Then we come to our adapter. We also come to the adapter section. Then we click on actions and again manage IP addresses. All right. Then we select this adapter and click on disable the auto assign public IP. We save and confirm. All right. So we go back to our instances. So now if you check, both server 1 and server 2 do not have the public IP version 4 address again. So now we can now serve the HAProxy IP address to the customers. All right. So let us confirm if our traffic is distributed evenly and correctly. Okay. So if we send a request to HAProxy, the first request should be sent to server 1, and if the second request is sent to HAProxy, the second request should be sent to server 2. Then since it is in a cyclic mode, it should repeat server 2, server 1. So guys, we have understood that load balancers distribute traffic, reverse proxies sit between users and servers. So an HAProxy does both. All right. So if this video helped you, please like, share, and subscribe. See you in the next video.